We don't want to actually use our brain and do things. But SOHCAHTOA is applicable. It helps us to ensure that we have the certain angles that we need without maybe possessing the tools. It ensures that we have the correct side lengths of things. It's used in architecture. It's even used in silly things like sports, getting your volleyball court nice and square in your backyard. There's so many applications of SOHCAHTOA, but in math in general. So many times we learn things and we don't use it because we're too busy trying not to look uncomfortable. I have literally sat in car dealerships and taken out my calculator. And let me tell you something. When you're buying a car or something like that, and you take out your calculator and start calculating the interest rates and all, their whole demeanor changes. It's like they're like, well, okay. It's like they're all of a sudden they stop being the pushy car salesman, and they start actually giving you.
You give them the finger.
But I mean, truly, when they're sitting there figuring out, how much it's going to cost you, and you whip out your calculator and you're doing it at the same time, their whole attitude changes. It's like it's almost very intimidating to them. They might laugh at me when I walk out, but I don't care because I make sure. I remember, and this was a very long time ago. I was probably about 22, maybe 23. My first brand new car that I bought. I had just started working full time. I bought it's my favorite car of all time. It was a red Dodge Daytona. And when I bought it, I went in and I knew exactly how much my payments should be. So back then, I don't know if they still do this now. I don't remember now, but when you buy a car that you were financing, you'd do all the stuff, paperwork, and then they'd send you over to the finance office, and you'd sit with the finance officer, and he would go through what it was going to cost you. And I'm telling you what, I went in there, I had my calculator with me. I knew exactly what it was going to cost me with the finance rate. And the guy, I forget the actual numbers now because it was literally 45 years ago. But I remember, it was like it should have cost me maybe $200 a month. And the finance officer's like, okay, that'll be, it's going to come out to $280 a month. And I was like, what interest rate are you using? So he told me the interest rate, and I'm like, no, it should be like $200 a month. Oh, well, you have your service plan in there. I say, I didn't ask for a service plan. Oh, you don't want a service plan? No, I didn't ask for a service plan. So he takes that out and he's like, okay, well, that brings it down to $235. Like, it should be $200 a month. And he had all these little things like hidden in there until finally he goes, you don't want anything. You just want to finance the car. I'm like, yes, I just want to finance the car. Until they finally gave me the actual rate that it should be. So it's important. Don't worry about whether you're going to look nerdy.
Car salesman versus math teacher.
Yeah, don't even try. It's like, no, you need to know your facts. Okay, unless you just have so much money you don't care. But I've never been in that situation, right? You need to know your facts. You go in, you know exactly what it's going to cost you. Okay, I've had that type of situation so many times. I remember one time my kids were so humiliated they literally walked out of the store, and they were little. They were like, I don't know, maybe 9 or 10 years old. And at the time, Skechers had just come out, right?
Oh, no way.
And my 9-year-old son wanted Skechers so bad, and we didn't make any money. I was like, I am not paying that kind of money for sneakers for my 9-year-old son who's going to grow out of them in 6 months. Okay. So, and I told my son, I was like, no, they're too much money. We're not paying that kind of money for your Skechers. I don't know, but we didn't buy like fancy name brand sneakers back then, So they had just come out, and my son's like, oh, Mom, I really want them. Skechers. And then what was the other one? The Sambas for soccer. Oh, my word. Gotta have sambas. But anyway, so my kids, they thought they were just being, they were like, my son comes up to me one day. He was like, he's 9 years old. He comes up to me and he's like, Mom, there's a sale at this particular shoe store and it's 45% off. Can I get Skechers now? So like, okay, we'll go to the store. We'll look. And sure enough, sign says 45% off. It actually specifically Skechers, right? So we go in, we find the Skechers, they fit. The kids are so excited. They're like bouncing up and down because they're going to get their Skechers. We go up to the register and there's like this, 17-year-old girl working at the register. And we put the Skechers up there and she rings it up and I'm like, no. What do you mean no? It says 45% off. Yeah, no, that's what it did. It's like, no, that's not 45% off. It was like 30% off. She goes, yeah, look, I scanned it and I don't care what you did. That's not 45% off. And I'm not paying that because the sign says 45% off. And she stood there and she argued with me. And finally I was like, can I see your manager? And at that point, the kids were like, Mom. I walked out the door and stand outside the door. Well, sure enough, the manager comes up, looks at it, and he goes, oh, we didn't reprogram the register. It is not giving you the 45% off. I'll fix that and gives you the 45% off. So I'm like, you have to know. Like, you would have been like, okay, good, great. Right? You got to know.
I would definitely know.
You got to know. I was upset. Well, I didn't do that because it was just some poor girl that was just, scanning it into the register. You have to know. Okay.
Was it 45% off on each sneaker or the regular free? What?
You don't buy a single sneaker.
I mean, you could probably
on the pair of sneakers.
No, didn't you buy 2 pairs?
Yeah, it should have been 45% off on each.
Yeah. Not the.
That was the scam they're trying to do where it's like 45% off and then 5% with a purchase.
Yeah.
Oh, fun. No, the buy one, get one things. Yeah. Okay. All right. So let's talk about SOHCAHTOA. SOHCAHTOA. You're going to be doing that all day. SOHCAHTOA. Okay. SOHCAHTOA. This is literally the first thing you learn about trigonometry. SOHCAHTOA. SOHCAHTOA. I'm doing that at my son's wedding, I'm telling you. Because I can't dance. I will. And he'll laugh because he's a physics teacher. He'll get a kick out of it.
Can you take a video of that? We can watch it here.
No, because then you'll laugh at me.
No?
Yeah, you will. You can't even say that with a straight face. Okay, so what does SOHCAHTOA stand for? Sine. Right? The sine of the angle is equal to opposite over hypotenuse. The cosine of the angle, abbreviated COS, is equal to the adjacent over the hypotenuse. That's theta. The tangent of the angle is the opposite over the adjacent. You must know this. This is trigonometry 101. You must know this. Okay, that's the way of remembering the ratio of the sides to the angle of a triangle. Okay, it has to be a right triangle. It's not any triangle, it's a right triangle. So if I'm looking at a right triangle, that means one of the angles has to be a right angle. Okay, here's my right angle. So one of my angles we're calling theta. Remember we talked about this last week. Theta is a Greek letter that is most commonly used for angles. Sometimes it'll be alpha or beta. Those are Greek letters used for the angle. It could be X, could be Y. So the sine of the angle is the opposite over the hypotenuse. The hardest part about this is recognize which side is the opposite and which one's the hypotenuse. The hypotenuse is always opposite the right angle. Okay? Don't think of it as a slanted because they'll draw tricky triangles. Okay? And they'll try to trick you. Like for instance, they might take this triangle and they might do that. Right? Now the hypotenuse is not slanted, is it? Okay, the hypotenuse is always opposite the right angle. Do you wish you could do that in your notes? Okay. Uh-oh, I just upset the computer. Oh, no. Okay. So, where's the adjacent and the opposite sides, okay? When we're looking at the angle, so here's my angle right here. Oops. Here's my angle right here. The adjacent side is the side that touches that angle. Now, if you notice, I have two sides that touch that angle, but one of them is the hypotenuse. So it's the other side that touches the angle. So that's the adjacent side. The opposite side will be the side that that angle points to. So there's my opposite side. That's the hardest part about SOHCAHTOA, just being able to figure out which side is opposite and which side's adjacent and which side is hypotenuse. Okay. Okay. So if I have, let me go back to our notes here, wherever they are. Okay. Let's look at, this is on page what? Page 5 of your notes. Okay, let's pull those out. Oh, it's not in there. No. Everybody find their notes?
Yeah. Because my notability doesn't work like the video to write, so I'm not able to write.
I do not have a paper copy, but you can just kind of copy the notes.
Okay, that's what I did.
Yeah.
I'm just not able to write it all.
Yeah, it's okay. Okay, so we know that, okay, let's label our opposite and our hypotenuse and our adjacent side. Here's the angle that we're referring to. So where's the opposite side? Give me the letters identifying that side. BC, there you go. So this is my opposite side. Where's my adjacent side?
AC.
And my hypotenuse? There you go. Okay. Okay, so sine is equal to what? Sine theta. Let's do the actual letters, the sides of the triangle. So sine is going to be BC. over AB. Okay? And this is opposite over hypotenuse. Cosine? What's cosine going to be?
AC over AB.
There you go. And that is adjacent over hypotenuse. And tangent is going to be, there you go, BC over AC, which is opposite over adjacent. Okay? Now, cosecant, secant, and cotangent, these are the reciprocal of sine, cosine, and tangent. So cosecant is the reciprocal of sine. It's abbreviated CSC, cosecant. And that's going to be our hypotenuse over the opposite. I will be totally honest with you. I usually do not even worry about whether it's hypotenuse over opposite. I just know it's the reciprocal of sine. So I just memorize SOHCAHTOA, figure out sine, and flip it. Okay, I'm not going to memorize cosecant as hypotenuse over opposite. I just flip it. Okay, so secant is the reciprocal of cosecant. That's your hypotenuse over your adjacent. So I'm flipping cosine. Okay. Don't get confused, right? Cosine does not go with cosecant. I wish it did. It would be really nice if it did. Right? Cosine goes with secant. And then cotangent, of course, abbreviated COT. That's going to be the reciprocal of tangent. So it's adjacent over opposite, which is AC over BC. Okay. So these are the 6 trigonometric identities of a right triangle. Okay. Everybody got that? Yes.
Is there a reason why cosecant is sine and secant is cosine?
No, I wish I have no idea what their reasoning was there. It just makes it so, because everybody, that's the biggest mistake that people make. They do cosecant and cosine together. Yeah. Okay, we're going to skip the common triangles for now. And let's look at example 2 down here. Okay, let theta be an acute angle. So I'm just going to label theta right here. Since it's an acute angle, it's one of the angles that's not a right angle, because how many degrees are in a triangle? 180 degrees in a triangle, right? And if I have one of them as a right angle, that means I have 90 degrees left, split between the other 2 angles, which means both of those angles are going to be acute angles, okay? Okay. We have an acute angle such that the sine of theta equals 5 over 6. The sine of theta, the opposite over the hypotenuse, equals 5 over 6. Well, let's label our triangle. The opposite to theta, that's going to be right over here, so that will be 5. The hypotenuse is 6. Evaluate the other 5 trigonometric functions of theta. So we have a total of 6 trigonometric functions. We already know one of them is 5 over 6 because they told us that the sine of theta is 5 over 6. Okay. Well, cosine is the adjacent over the hypotenuse. Well, I know the hypotenuse is 6, but I don't know the adjacent side, because the adjacent side's right down here. How do I find that side? You have a right triangle, you know 2 of the sides. How do you find that third side? Pythagorean theorem. Who remembers Pythagorean theorem?
You said it right.
A squared plus b squared equals c squared. Has to be a right triangle. Remember, this is all right triangle. So that means I have 5 squared. I'm going to call it x instead of b. X squared equals 6 squared. So we have 25 plus x squared equals 36. X squared equals 11. So x equals the square root of 11. So my adjacent side is the square root of 11. Does that make sense? How do we check that? Square root of 11 squared plus 5 squared equals 6 squared. Is that right? 11 plus 25 equals 36. And yes, that's true. Okay. Okay, so what's the cosine of theta? Square root of 11 over 6. How about the tangent? Yes.
If you do it and it ends up with the square root in the denominator, do you need to fix that?
Yes, we do have to fix that. Yep. Because we're going to see that on the tangent. So tangent is opposite, which is 5, over adjacent, square root of 11. Now we can't leave that square root down there. Remember our rule? Move and remove. So we're going to move it up, move, and we're going to remove the square root from the denominator. That's our little shortcut trick. Move and remove. Okay?
So your answer would be
5 square root of 11 over 11. Okay, how about the cosecant? That's the reciprocal of sine. I already found sine, so we'll just flip it upside down. 6 over 5. Okay. So secant, that's going to be the reciprocal of cosine, so that's 6 over square root of 11. We're going to move and remove it. Okay. Now the cotangent, I'm going to flip it, but I'm going to flip it before I did the move and remove. Because if I flip it here, it's going to work out cleaner. Square root of 11 over 5. If I flip it here, then I'm going to have a lot of extra work to do. Okay, so we flip it in before we simplify it. Okay. Okay. Let me just pause this a minute because I don't show you something in these first 4. Okay. 2 of these triangles are very common right triangles, number 1 and number 3. So when you see these ratios, you should be able to come up with those sides very quickly. Okay, this first one is what we call a 3, 4, 5 triangle. The legs are 3 and 4, and the hypotenuse is 5. This is just a multiple of that, 6, 8. Oops, this is 10. I wrote a 5 there, which means I made a mistake on all of them. 6, 8, 10, right? It's a 3, 4, 5 triangle. So I didn't actually have to use Pythagorean theorem to figure out. Oh, so sorry. Right? I didn't have to use Pythagorean theorem to figure out that triangle because I knew it was a 3, 4, 5 triangle. Okay, as soon as I saw the 6 and the 8. The same thing with number 3. That's another very common right triangle, 5, 12, 13. So if I see any multiple of that, I don't have to even use my Pythagorean theorem because I recognized that triangle. So as soon as I saw both of these, I right away filled in those sides, right? You should recognize those also. This is a 3, 4, 5 triangle. It's just a multiple. Everything's multiplied by 2. This is a 5, 12, 13 triangle. Remember, in a right triangle, your hypotenuse is going to be the largest side, the largest number. Okay? These are things that help you, especially on your SAT. It's going to help you be more alert to stuff, right? Your hypotenuse is the longest side on any right triangle. The hypotenuse is the longest side. Okay? And then I recognize these two triangles. Number 4 is a common one also, but not as common. And I didn't recognize that until I did it. But number 1 is a 3, 4, 5, and number 3 is a 5, 12, 13 triangle. Okay?
How did you get 10 on the first one for the angle?
I didn't get 10 as an angle. What are you talking about?
Or not the angle.
For the hypotenuse? So this is a, right? This is a multiple of 3, 4, 5, right? 6, 8, right? So what am I doing? I'm multiplying by 2. So if I multiply the 5 by 2, I get 10. So this is 5 squared plus 7 squared equals c squared. So that's 25 plus 49. 25 plus 49 is 74. So c is the square root of 74. Okay. Okay, number 5, right? This is just like the examples we just did. All right. Make your triangle. Don't try and do it without drawing the triangle. Just draw the triangle. Label an angle. So I'm going to use this angle right here. So sine is opposite over hypotenuse. Okay. Look at the next triangle. It doesn't matter which angle you use. Okay, there's my angle. Tangent is opposite over adjacent. Well, what do you see? Right away, this is one of my common triangles. 5, 12. So what's this side? 13. Okay. Saves me a lot of time to recognize that triangle. Okay. Cosine is adjacent over hypotenuse. Now be careful because that 5 and that 8, you're like, oh, is that a 3, 4, 5 triangle? No, it's not. That is not a 3, 4, 5 triangle. Okay, and then secant, again, I don't think in terms of secant and cosecant and so on. So I'm going to flip this. That means cosine is 15 over 17. Okay, so cosine is adjacent over hypotenuse. Okay. And there's one that we know, right? There's a common triangle. We already had that one up top. We had one side is 15, the other side is 7. The hypotenuse is 17. So what's the other side going to be? 8. So save us some time, all right? Do we have one with the 11? No. And we don't have one that's 5 and 8. Okay. Okay. So you can finish the rest of that for home. Actually, I think we'll just stop there. I'm trying to cram too much in. You can finish this and we'll pick up on actually tomorrow.